Hello students, today we are going to finally complete all the numericals of the circular motion. Hope you would have seen the first and second video of the numericals. We will continue to see the last part, which is motion in a curved path, and the numericals based on this we will see. Already we have done the derivation based on this. I will just give a quick recap of what are the derivations that we have seen and the implications of that, and then we will get into the numericals. So we saw the one of them is bending of cyclist or motorist or whomever is going in two-wheelers. Why do they bend? And when they bend, so when there's a curved path, the cyclist also will bend, and the handlebar, everything it bends. So you've seen this one, it is not straight, they don't come in straight, they bend with an angle theta here. And they come with a good velocity, they come with a nice velocity also. So we get this formula as, because they are bending here like this, there is an mv square by r, which is the centripetal force will act, and there is a frictional force will be trying to keep them inside. These two has to be equated, that's all. When you equate this one, and also there is a bending which is there, which it also bends along with this one, right? So you get here tan theta is equal to v square upon rg. This is the final formula that you will get. What is the angle of bend? You will get this one. V is the velocity of this cycle, and r is the value of the radius of this one, and g is going to be the acceleration due to gravity. Okay, so that's what the basic thing it says. There is nothing much about, you will not see the result of friction and many things. It is without friction you will see this one. That is, in the formula there is no value of friction which will be there. The second part is, when a vehicle is moving in a curved path like this, when a car is moving in a curved path like this, and it is just flat, and there is a car which is going, so we know this car is coming, so when a car is coming like this in a curved path which is not banked, this is a straight path like this, so the velocity is going to be equal to under root of mu into r into g. You will get, this is velocity of a car going in a curved path without banking, it is not banked, and all that force when it coming, the force of centripetal force mv square by r, it is given by the frictional force here. So these two has to be balanced together, then only it will be staying on track. So mass gets cancelled out, so you get only this one. Without mass you will be having this. Now we'll see the third question which we see, that is the track which is banked already, and we know there is a banking of roads, and this is theta here, and there is a car which is coming on a banked road. So you will see how that one behaves. So when it comes in that bank road, definitely we have a lot of other components will be included in this one, and the final formula, what happens to the formula of velocity, you need to see this one, is v is going to be equal to under root of rg tan theta plus mu upon 1 minus mu tan theta. So that's what the formula will be. It is full under root. This one, it is with friction. Friction is also there. Mu is there. When mu is going to be equal to 0, when mu is 0, there is no friction, and the car is going in a banked path. Okay, then what happens? We have to see accordingly also how it will change. So that also we can see, it's going to be v is going to be equal to So when mu is equal to 0, this will become, whole thing will become 0 here. There's only 1 here, and then this is 0. So it's going to be V is going to be equal to under root of Rg tan theta. Okay. So remember, this banking, this banking is wrong. The diagram which I have drawn, this banking is a wrong diagram. So this one is capable of sliding this more. It will not be banked here like this. If it is curved like this, it will banked, the outer edge will be banked in this direction. So don't ever think all the banking diagrams, anywhere you can bank it. So a bad example will give you a good lesson also. So how will be the banking actually works? It is good to pass here and explain that one. When a curved path in this banking, so it should be, the curve should be like this. Then it banks like this. So the curved part of it, listen here, the curved part of it should have an acute angle. This is the sharp place, and the broad part of it should be there, the other side. Alright, now look at this one, it is reverse. It should have banked like this then only the car will be exactly negotiating properly. Otherwise, this is a very much total wrong engineering then. Okay, when you have the car is anyhow, it is going to have a very good difficulty, and at the same time you are banking also in the opposite direction. I hope you are able to understand this one. So in this one, this is the right example. You would have already seen the diagram also, how it is been given here. So this is the actually example of here. Theta should be here. So concluding, when you curve this one, this is this inner curve, that side you will get a sharper this one, and the bigger part you will get a lot bigger one. Okay, if it is this curve is there, if the curve is like this, how will you bank? What will be the banking in this one? This is the inner curve, this is a smaller circle, and it should be, this should be the smaller one. The nose should be here. This is a tipping nose is here, so it should be like this. Right? In the examination also, don't mess up. The way of diagrams can be quite taking you in a different style altogether. You can say that, oh, anything is fine. No, anything is not fine here. You should understand how it works. So this is the way in which it will be working out. Okay, now we'll go to the numericals now. So we are going to see a numerical which is in page number 313 page number, right? It is question number 15. Yesterday till question number 14 we did. Now we are starting with question number 15. Quickly read the question. So pause this video, read the question, and try to draw a diagram for this. And try to write the parameter also. I am giving a pause for some time. Read it. Understand. Alright, hope you would have read this one. So, a car is there, a good weight car, mass is 1500 kg, and then what is the speed? 12.5 meter per second, and then what is the radius of this curve? It is 20 meter. Now another thing which I wanted to emphasize is, in all this one, entire of a circular motion, you will find one very important formula will repeat again and again, is centripetal force. So centripetal force is always, it is a kind of a pseudo force which will ride on something else. So in a curved path, it will ride on the friction. Yesterday we were seeing all the stone which is tied, there's a string and the stone is tied here, and there's a tension here, and it is going around. Then the centripetal force will be acting here, mv square by r. That time what we saw is the tension and the centripetal force. Tension was the centripetal force. Now same illustration, now taken in the curved path, and a car is going here. Now there is no tension. You are not putting this one in a situation where you are not having a situation where there is a string which is tied and tension is prevailing. No, there is no string, and car has to negotiate. What is providing that centripetal force? Frictional force will provide. So frictional force will always contribute to the centripetal force. Centripetal force cannot remain as alone. It always needs something else. Remember that. Centripetal force and then the value of tension is there. Centripetal force and value of friction is there. So here, what should be the frictional force between the car and the road so that the car does not slip? So it is quite a straight question which is asked. So frictional force, you will find it is going to be equal to mu into r, which is going to be equal to mu into mg. That is the frictional force. Centripetal force, what is that one? Centripetal force, F is going to be equal to mv square by r. Alright, this r and this r is different. What is this r? It is reaction, which means it is going to be m into g. What is this r? It is radius of the circle. Okay, now what is asked? They are asking what is the frictional force? How much would be the frictional force between the car and the road? That's what it is asked. This is the big question here. This is the question here. What should be the frictional force? Okay, so go ahead. So can you try this one? How it will come? How will you find out the frictional force? What is the basic parameters you need to do to get the frictional force? It is nothing but frictional force is equal to centripetal force. So remember that frictional force should be equal to centripetal force. So the first question is, what is the frictional force? It is just F is going to be equal to mv square by r. You find out this, you will get a frictional force. To stay on the track, if it has to stay on the track, it should be equal then. So what is the parameters? 1500 into velocity is 12.5 the whole square and divided by 20, and you will get the value here. The value of force will be getting, that is frictional force. You will ask, sir, you tried only centripetal force. How can we say that it is a frictional force? The frictional force should be equal to the centripetal force. So you got this answer. You would get this answer maybe from this book. If I wanted to just write down the answer, it is 10 to the power of 4 newtons you will get. Okay. Now the next part is, the second part is, it is asked, what is the coefficient of friction? What is the coefficient of friction? Now you can equate both this equation number 1 and equation number 2. You can equate this. Try to equate this one. You will get coefficient of friction mu. You can find it out, right? So mu is going to be equal to mu into m into g is going to be equal to mv square by r. Mass gets cancelled out. So what is mu is going to be equal to v square upon rg. So 12.5 the whole square upon radius is 20 into 9.8, and you will get mu. So the mu, if you do the calculation, it will be 0.8. Quite simple. These questions are not tough, very simple, but it has to just be knocked in the right direction. You will be able to do it. Okay, we'll go to the next question now. Turn to the next page. So this question says, a cyclist speeding at 18 kilometers per hour. So 18 kilometers per hour, we already know it is going to be 5 meters per second. On a level road, takes a sharp turn. So the cyclist is now coming on a sharp turn. On a level road, he is coming, and then straight away he is making a sharp turn. The velocity is already, it's going to be 5 meters per second. It's already given 18 meters per second. It is kilometers per hour. It is 5 meters per second actually. And then radius is given here as 3 meters, right? And of radius, without reducing the speed, he is just coming the same speed. The coefficient of static friction between the tires and the road is Mu is given here as 0.1. Will the cyclist slip while taking a turn? So the turn is so much sharp. Will he slip? How will you find out this? Try to think over it. What could be the parameter we should put so that the cyclist will not slip? The cyclist will slip when there is no friction. Okay. So friction is the main thing. So we'll see that cyclist is coming, and then he is straight away coming with a good speed. Now the friction is going to be acting in this direction, frictional force, and the centripetal force will be acting in this direction. Alright, equate both is 1, and we have to find out what will be the value in which it will be there. So as we go ahead, we see the main point is the velocity. Greater the velocity, the higher chances to slip. So let us try to equate, the frictional force should be much greater than or equal to mv square by r. Right? Then only he will not slip. So mu into m into g should be greater than or equal to mv square by r. Right? Then mass can get cancelled out. So what is v square? It should be less than or equal to mu into r into g. This has gone here. So what is v should be less than or equal to under root of mu into r into g. When the velocity is this much value, maybe velocity is equal to this value, then he is safe. Velocity is greater, we need to see where he will not be able to, he will be slipping and falling. So it is asked, will he slip or not? Based on this velocity, you try to find out. All the parameters are given. Mu is given, 3 is, r is given. So when we put this value, v is going to be equal to under root of 0.1 into 3 into 9.8. Alright. When you use this value, the safest value, we will not put 5 here. Don't put 5 here. We will try to find out this answer, how much it will finally land you up with. Okay. So this will be landing up at, this is going to be how much? It's going to be 1 and 3, and it's going to be approximately 1.7 you will get. Alright, 1.7 you will get as an answer, meter per second. Okay. So if he comes in this much minimum second, then he will not slip. More than this velocity, minimum is, it should be less or equal to. Velocity should be less than this or equal to. How much velocity is coming? 5 meter per second. This Maharaj is coming in 5 meter per second. Now he will fall or not? Yes, he will fall. So what will write the final answer? Yes, he will slip. Right? He will slip. That's the final answer. Hope you are able to get this idea. Remember, whether he will slip or not, you find out the velocity. If the velocity is higher, then he will slip. Velocity is within this limit, then he will not slip. Okay. Can you go to the next question? Question number 17, it says, a car of 2000 kilograms. So this is the mass of the car, has to go over a turn whose radius is 750 meters and the angle of slope is 5 degrees. So this is a curved path. Now tell me which angle you will be doing the banking. There is the angle of slope is given 5 degrees. That means the banked path you will put like this or you will put like this. Think over it. Nose tip, where it should come? It should come in that inner circle. So this should be a nose tip, not this side. So you will get like this, and this is 5 degrees. It's already given. And the car is now negotiating this path. So as it's going like this, the mu is given here as 0.5, theta is given as 0.5 degrees. What should be the maximum speed of the car that it may go and turn without slipping? Speed is asked. So you have the formula already. Rg into, what is that formula here? Rg is equal to tan theta plus mu the final formula of derivation that we already seen, 1 minus mu tan theta. Just now also I already wrote the formula once again. This formula you just put in, everything will be right. So r is there. What is that? The radius is already given here, 750 meters. 750 meters. And then tan theta, it is tan 5. Alright, tan 5 is the value. And then next is tan 5. If you see the value in the log table, it is 0.875 will be there. This is tan 5. Or if you have a scientific calculator, you just put tan 5 and tan theta, you will get this answer. Substitute this value, you will get the V value. So that is the final thing. If you put all the value here, it will get 67.2 meter per second. When you do it, don't just put this and jump to here. Please substitute everything. In the notebook, I will see whether you have substituted everything and written properly the answer. Okay. So that will be the thing. Straight away substitution of this one. Go to the next question now. A circular race track of radius 300 meters banked at an angle 15 degrees. If the coefficient of friction between the wheels in the car is 0.2, what is the optimum speed of the race car to avoid wear and tear on the tires? And what is the maximum permissible speed to avoid slipping? There are two things there. He wants to save the car, keep the car as new as possible to avoid wear and tear. That means you have a race car and you don't go so fast. Is it possible? He is asking for that. Optimum speed of the race car to avoid wear and tear. So he doesn't want to really wear and tear the tires. It will be very much as new as it could be, and still you want to race it. That's the A part of the question. Second part is, okay, I will race it as much as possible, but I should not slip and fall down. Very good. That is also good thought. So first thought is, I want to run the race, but I don't want to wear and tear this one. So V, velocity, the maximum velocity is, again can you write the same formula here? You should be able to write now without seeing the book. It is tan theta plus mu upon, what will be the denominator? 1 minus mu tan theta. Okay. Now the first part of the question, will it fit in this one? Angle of banking is there, tan theta is there, mu is given here, radius is already given here, g is already there. What it is asked, optimum speed wins minimum velocity. The velocity has to give so that he will not have wear and tear. If you don't want to have wear and tear, means you should have friction is equal to 0. Then only you will not have wear and tear. Your tires will be wearing and tearing, means because of friction only. Let us assume friction is 0 here. Okay. When mu is going to be equal to 0, okay, you can write down during optimum speed. This man has bought a race car just for a show off, but he wants to go slow. Optimum speed. Okay. Mu should be equal to 0. So put this one value V is going to be equal to under root Rg tan theta will be this one. Because mu is 0 here, mu is 0 here, then you will get this value. So V is going to be equal to under root of, what is R? 300 into 9.8 into tan 15. Put this value, you will get the final answer. Okay, this is the minimum speed. This is the slow speed, you can say, go in this speed at least. Maximum you can go in the speed so that you will not have wear and tear. Okay. The next one is, what is the maximum speed? This is V minimum. Alright, and then in the minimum speed you will not have any problem. Maximum speed is this one, V max. So the maximum speed, the B part of the question is, this is the A part of the question, B part of the question is Rg tan theta plus mu upon 1 minus mu tan theta. Remember children, this was already taught in the derivation. It's a big derivation we saw, and that same final formula is coming again and again. So V max is going to be equal to, substitute 300 into 9.8 times of tan 15 plus 0.2 upon 1 minus 0.2 into tan 15. So this is a big calculation. What is tan 15? Tan 15 degrees, here it is given here as 0.26979. 0.2679 is the value. So you put this value, you will get the final value here. Okay. So minimum and maximum value will be able to get. I hope you got the idea. What is the idea is, you don't want to have any kind of wear and tear, use this one, use this formula. You want to go on a maximum speed, good speed, thrill is there, you go with this one and wear the tires, no problem. Okay, now we'll go to the next question. This one is a really interesting question, where it is not in a track, because it's an aircraft. An aircraft executes a horizontal loop at a speed of 720 kilometers per hour. Horizontal loop. What is a horizontal loop? So it's a word, not a vertical loop. Aircraft is also going through an horizontal loop. So have you seen an aircraft when it is going in a thing? The aircraft used to sort of bend like this. So that will be a side bend you will get. Have you seen that one? The aircraft will make a slight bend of that wings when it is making a loop. When it is going on a loop, it will be just making a kind of this wing will tip down and this wing will go up, and there will be an angle will be created. If you are sitting in the aircraft, you will see that will be an kind of a thing. That's what it is asked. So look at this. It's quite strange, no? There is no road, and it is just an aircraft. Even when it is executing the loop, it is also going on a kind of an tilting. So you are a cyclist, or you are a car person, and you are a person going on an aircraft. That also happens the same way. So in this one, what is the radius of the loop? What is the radius? They are asking question. What is the speed they are going? 720 kilometers per hour. That is equal to 200 meter per second. Right? It is going to be 200 meter per second is the speed. And then angle of banking is tan theta is given there. Tan theta is going to be equal to tan 15. It's going to be tan 15 is there. So what is the formula will be used? What formula you will use? So it's going to be straight, the same formula where you will be using for the bending of cyclist and the velocity. These all things are going to be same. So it's going to be equal to tan theta. It's going to be equal to v square upon rg. Alright. So radius is asked, r is asked. So v square upon tan theta into g. This will go up. There's no friction here. Okay, there will not be any friction. So radius you can find out. V is already 200 square. And it is tan 15 into 9.8. So you'll get the answer here. Okay. In the book, the answer is 16 kilometers is the value. And it just slips, makes a kind of a tilt like this. Immediately you are going to loop it around a 16 kilometer radius. Alright. So that is the simple question. We'll go to the last question now. Okay, the last question talks about which vehicle is moving. We saw a cycle, we saw a car, we saw an aircraft. One thing is missing. Train is missing. Now train is also here. A train rounds an unbanked curved circular bend. Now listen here. Train track also is sometimes could be banked. Train also is banked because some of the sharp turns you need to bank it. But here this is unbanked circular bend. So that means it's a straight curve which is like this and without any banking. So train is just coming on this one. Okay, the radius of this one is 30 meters. And the speed in which it is coming is 54 is given here. The velocity is going to be 15 meter per second. 54 means 15 meter per second. The mass of the train is given here as 10 to the power 6 kilograms. What provides centripetal force required for this purpose? Which one will provide? Engine or the rail? So the question is, your engine will provide the centripetal force or a rail? Remember, the rail only will provide. Engine will know only to run the machine. The rails will be providing. Okay. And also, which rail will be providing the centripetal force? The outer rail will be more amount of pressure will be there on outer rail because it will be trying to come to the other side. It is trying to keep that flow inside the circle. So outer rail will have more amount of pressure. Is outer rail or inner rail? So we said rails. Now outer rail, inner rail, it is outer rail will be contributing more to the centripetal force. Hope you got it. Which rail will wear out fast? Outer or inner rail? Yes, outer rail will wear fast because that is going to be the taking this one. And what is the angle of banking? And to prevent this one, you have to have, if you want to have a banking here, what should be theta? So that's what is asked here. Okay, let us do this question now. So already we saw that is tan theta is going to be equal to V square upon Rg. That could be the angle of the banking. So you put the values here, then you will get tan theta here. Okay, so velocity is 15 square upon radius is 30, and then G is, what is G? 9.8. Now mass is given, mass has nothing to do with here. You just put this value, you will get this. So listen here, it is so important, pertinent to see this one. You could have a small tiny vehicle coming with less mass. You can have a huge mass like this, 1 followed by 6 zeros also it can come. Alright, this many kgs also it can come. It is immaterial. Angle of banking means it always depends upon the velocity only. More the velocity, then more banking should be there. If the velocity is 15 meter per second, it's already told danger zone, go on 15, that much angle of banking you can have. It does not depend upon the mass of the vehicle. It depends only on the velocity of the body. How much velocity is there and the radius of this one also. So if you have bigger radius, then you need not have more of banking. If it is a sharp turn, then you have more banking. So you put these values for this much speed and this much of radius, it just takes a combination, you get the tan theta value. Alright, so here it is given here as the answer is 0.7653. I'm just writing it from the book. So it's going to be equal to 37 degrees. That's the angle of banking. It's quite a big banking. The banking is quite good. Good banking is there. So that is the thing. With this question gets over. All the example questions I have done. Now you will be doing the exercise numericals. You need to turn to page number 326. Based on motion on curved track, banking of roads and railway tracks. Alright. So there are 8 questions are there. These questions are homework for you. Try it out yourself because it is interesting to do it yourself. Then only you will get a practice. Please make honest effort to do it. If you have any problems or any question which is you are not understanding, please WhatsApp me or message me. You will be able to. I'll be able to work out in the next lecture which I am giving on tomorrow. So 20th to this one you try yourself. That will be great. Alright children, thank you. Wish you all the best.